Assalamu alaikum. Welcome back to my channel. I'm Nizar here. So in the last video we learned how to make this SLD, and I explained you everything, these things, and the capacitor bank, and then transformer and generator. I explained about you the ATS, and also I explained how ATS will work, and also I explained about the SNDB1E, that meaning emergency SMDB, and I explain about the feeder pillar which we are using normally in external normally. So here, but I didn't put in the external, just I put it here because I named this one as feeder pillar. If you see in my previous drawing you will know, because I didn't put name tag here, so it will be just waste of time. So consider this all normal SMDB, and this is emergency SMDB, and this one feeder pillar, and also explain this. So we will go for the next step. So here I have 8 panels. So 1 2 3 4 5 6 7 8 panel. So 8 panel, it's a similar panel. So this is total connected load. It will be multiplied by 105.66. So let's go to the calculator. So I will type 105.66 into 8. So I have total connected load 845.28 kilowatts. So let's type here total connected load 845.28. Let's break this one. So this one I will change color, so I will know I have changed this one already. So this one, let's name it MDB0 MDB, let's say 01. Location, this is leave it as it is. This is MV room, we don't put in the LV room, this is MV room. So the project MV room, what I work there, MV room call as LV room. So that's not a big deal. Okay, now I have 845 point, actually 28. So I have some feeder pillar here with the emergency. So this load is not correct. So here I put some lights. So this feeder pillar I am going to feed this light. In case of power failure, so emergency generator will start. I didn't draw any generator room here. So generator will start, it will feed the power to the SMDB, emergency SMDB, and it will feed to the feeder pillar. From feeder pillar it will feed these all lights. So let me select similar, right click, select similar. So let's copy. So I need light here. So there will be light here. Let's copy, click. I need array. Let's put 10 lights, and we will make a fit up to here. I think 10 light is too much. Let's delete this one. And this is not a perfect drawing. My purpose is teaching you the electrical, not the architectural, so I will just draw only the concept drawing. Normally it will be not like this. Let's move this one. So I will copy same here. Not it like this. I will I'll select only this, copy, and so copy, also copy here and here and here. So let's select this all light, select similar, let's delete it, enter. So I will have 120 light deleted, so let's undo. So let's say one light is 50 watts. Just I want to get the load. You have to make for the feeder pillar also same like dB schedule. And so let's go for the 120 lights. Each light we will consider 100 watts. Let's type 100 and divided by 1000. So it is almost 12 kilowatts. Almost 12 kilowatts. Let's put 12 here. So here. This is the feeder pillar dB. 12 kilowatts. Okay. So demanded is all light, so we can go for 50% as I remember. So we will go 6 kilowatts. Check the Karma book if I am wrong. So there will be another dB. I need another dB. Let's copy the dB. That's one. Let's copy this one. Better I name it, otherwise it will confuse. So this one I will make small letter SC. I think this one enough. SMDB, ESMDB we will put, emergency DB -01. And this is feeder pillar, so we will name it FP01. Okay, no problem. Okay, so this is, we will put a name. What name we use here? SMDB CD. Oh, it's a block. Let's click X, enter, double click, copy. So let's put this one. It's big. Okay, let's go the properties, and width factor I will make 0.6. If you press Ctrl 1, it will open, or you can type PR. So this is 2, 3, 4, let's make 5, 6, and 7, and 8. So let's name it 2, 3, 4, let's make 5, 6, 7, 8. So this one I will copy, Ctrl Shift C. Let's put it here. Delete this. It's not correct one. I will put this one. Okay, and this one not correct. I will delete this. Let's put this one. Okay, I broke this. Ctrl Shift C and Ctrl V. If you press again Ctrl Shift V, it will paste as a block. I hope you know that one. So I need another panel here. For what? This panel for what? Let's put it here. This one I call DBHV. So same concept. If you know biology, your heart pump blood for all over your body, and the same time your heart need some blood to work itself. The same concept. So this panel, this whole panel providing everything outside, but this panel itself, they have dBs. So this dB we will put, copy, let's put dB LV slash MB. So we can use same dB for this two room, no problem. But for HV it should be separate. You cannot mix with this one. Because this one will be with the government. Once everything finished, they will lock and they will take the key. So this is cannot entered by us after finish. And there will be another dB. If you like, you can put. We can move this one here. Okay. Or we can keep there, no problem. So there will be another dB. We will put it another dB. TB, dB, TX. That's a transfer. So this all we need to connect in the to the emergency dB. In case of power failure, we need light. So let's put it in the dBTX. So let's draw another one. Okay, let's put it one box here. This we call generator room, and we have to draw some trench here. Right. Yeah, we can connect. Yeah, like this. We will put one manhole. Let's not be lazy. Do it. Okay. So this one we need to put it here. So as we have this one here, we will just shift this to here. Okay. So one power coming from here to here, we can put cable tray from here to here, and another power coming from the generator. I think 3 is enough. Let's make one now. It's a depend of the load, how much load you have, that much cable will come as per the calculation. So let's move this one little bit here. So you can put a drop it, same like this. Okay, let's make little smaller. So copy. So always we use 150 mm dia PVC duct. It's otherwise 100. It's depend on the requirement. So let's move this guy little down. So here I use 160. It's not necessary it should look like this. It can be any, maybe like this also. It's depend on the designing. Okay. So let's copy this one. Let's put it here. Let's select this all. rotate. Let's delete this all. Let's move inside. Let's make little smaller. Let's make copy 3. Okay, now this one, generator room. So let's make gen room. Okay, now perfect. So we need more dBs. I have dB LVMV. Let's copy. Then this one will be feed from here. Let's move this all to here. So it will be easier to feeding the power. Okay, so we have dB, let's copy this, dB LVMV. Okay, let's copy this one, another one, maybe I can put it here. Let's move this one somewhere else. Okay, so I need another one. Why I can put like this, and I need another one dB TX. I need another one dB HV. So here I am putting everything with the two power supplies. When the power available, it will come from the government, because I have ATS here. If no power available, it will come from the SMDB. So some design it can be changed. Sometime they will not use as I am using like this. So it's depend on the design. For me, I am thinking to use like this. So let's connect this guy here. One, another one, another one. Let's move this one little down. If you press Ctrl and if you click, only this line will select. Otherwise, if you click, all will select, because I am using polyline here. I hope you know this command. If you don't know, just follow my other video to learn AutoCAD tips and tricks. So this is dB. Okay, I have already dBFV here. Okay, let's delete this one. No, I should not delete. We have dbgen here. Okay, so perfect. So now I want to tell you another thing. This one I have ATS here. So ATS, it's get feeding from one from the Kaharma, that meaning from government's supply, one from the generator. Let's say this project no generator, totally no generator, and in that time they use some different techniques. They will put one UPS here. Let's copy this one. I will explain you. Copy. Instead of this one will be directly connected. Off on, let it keep it like that, but this one will be UPS. Maybe this one will be maybe 5 hour, 10 hour, it's depend how much battery you have. So this one directly goes to the power. Let's delete this cable to not to be confused. This whole cable here, it's mentioned here, I didn't calculate yet, but you know how to select the cable. Just if you're following up from me from 0, you will know that one. So let's come here. That one, it will be charged the UPS first, then it will give the power supply to the SMDB. From here it will go here. So when the power failure, this 5 hour power charging will give the power. When the 5 hour finish, this will be off, no more power. But here, when the generator fuel finish, it's no more. So same concept but different ideas. Instead of generator, they will put UPS. But generator, you can give more power to the more panels. The UPS, I believe this one will not fill all of this one. So what will happen? Every panel will be separate UPS. Something like this, one UPS here and 1 dB, and this one coming from power Karama, meaning government power, and this one will be like this. The cable will be same both side, here and here, and yes, this one. The amperage is depend on the load. You know how to calculate the ampere if you are following me up from the beginning. So something like that. Inside you will be see UPS here. So something like this, every panel will come. So this is one type of concept. Another concept, they put only for the light only. So some light, there is an emergency light call. Individual light, it will have 3 hour battery backup. So in case of power failure, that battery backup will be start to work, and then the light will be work up to 3 hours. But here it's giving power to the panel, so whatever connected to the panel it will work. So no need to you buy specialized light anything. So it will work continuously. It will work all the system whatever connected to DB. But emergency power supply, that meaning battery backup lights, which has battery backup light. Let's say they have 10 lights here. Let's say here they have 10 lights or 6 light, 1 2 3 4 5 6. So in that 1 2 light will be battery backup. It's depend on the budget. And there is another system also, central battery unit system. Central battery unit system, same concept of here. Normally it will be goes to the light, same concept here. Let's delete this, it will be confusing. Same concept here, but it will go one panel here, UPS. It will get power from the Kaharama. I should copy with this one, meaning government supply. In Qatar we call Kaharama. And this will go to the controller, UPS controller. There will be another controller here. It's the same box. Okay. Controller. From the controller it will go to the panels. Like panels like this. Specialized panel. From the panel it will go to the drive. It will go to the drive. They have one specialized drive. From the drive it will go to the light. Let's say, let's draw the light circle. So each drive have certain limit of light. So it will be another drive, another drive. So this will be continuously connected. Same concept of DB, but this is go to the drive. Something like this. And it will continue. So there will be many light. I don't want to draw. So there will be another. Something like this. So this is central battery system with the battery everything, and then the controller, the central battery unit controller, and then the DB, central battery DB, and then the drive, and it will go to the light. Sometime there will be another panel between this one. Let's draw that one. Oh no. LCP. So lighting control panel. If it is feeding some external or somewhere. So let's name this one. This is central battery system, CBS. Then CBS controller. CTRL. Then DB, CBS DB, we will put CBS DB, and CBS drive, and the light, this light. And there is some specialized system like DALI light, something, there is too many things. This one cannot be teach because everywhere different systems. So if you want to learn that one, you have to learn many things. So you just understand the concept, then wherever you go, whatever system available, you will understand. So keep in remember, if there is any specialized light system, any specialized except no, any specialized system light, there will be a control panel. Anything. Let's say they have one system which light can control by the remote. Sure, 100% sure, there will be a light control panel. Light control panel, specialized control panels, not light regular control panel, specialized. Because if they have remote will not operate light directly. The remote will operate to the sensor. Maybe they will install any sensor somewhere near to the light. The sensor will give command to the controller, then controller will switch on the light. If there is any specialized system you see for the light, there will be 100% there will be a controller. If it is regular system, directly DB to light, light to switch, finish. But if it is specialized, or DALI system or any other system, home automation system, anything you see, like a specialized controller through remote or through internet or through mobile application or anything, 100% there will be a controller. So don't forget that one. There will be a controller. So let's go back to here. This is all special system. These are the system available now. So I hope you understand. There's OMS home automation system, meaning I have worked one system called home automation system. This one you can control your light, your AC, your any device. You can control through the internet. uh, wherever you are, from internet, through your mobile or through your computer. So this one have some specialized panels. How it is working? It's a very basic thing. It's like the TV remote LED. So how? There is a panel with relays, too many relays. This relay, it will operate 240 volts, but to operate itself it need very small voltage. So it's a very, one coil is inside. Normally NC NO concept relay. If you check the relay, you will understand. So the relay will be controlled 240 watts. To work itself, it need very small power like 12 volts, something like that. So it's connected with some specialized control gadget. Can be PLC, programming logic control, or something which is invented. It can be this. Nowadays we are using Google or Alexa or something else. It's coming now some device. You can connect to the Google and you will say, Google, switch off the light will off. You can search in the internet. So something like that you will have specialized. And this one connected to internet. So there is a gadget already there, it is work with the internet. So what will happen when you give a command through the mobile, this gadget will receive the command, it will produce small amount of current to the relay which can operate this one, switch off the light and switch on the light. It can be done like that. It's very simple theory. Through internet, this gadget will receive the command and it will produce small current to the relay. The relay will operate with this small current. It will switch off the light, switch on the lights, something like that. So if I remember, there is one gadget called Raspberry Pi, I think, as I remember. Raspberry Pi. Yes, Raspberry Pi. So let's go for the image. So these are one kind of gadget. You see USB and you can see Ethernet controller, everything. This one maybe, I don't know correctly, but this is one kind of gadget as I know. And if you type home automation system, alright, this control panel. This is the home automation control panel. Let's go to the system. This type, but check this one, say this one. It's connected all through internet with the panel. There's another one I saw the internet, Google Home Light Control. Yes. I think this is the gadget. No, not this gadget. Let's see. I think this one. No. I saw something. As I remember, this Alexa light switch. Check in the internet, there is available something like this one, right? Borrow. Something look like that. You can control the light. It's a small concept. So let's go for the, let's finish this one. That can be, we can discuss in another video. And what else? Now I forget what I was telling to you. Okay, now this feeder pillar. I hope you understand this USB everything. And there is a, if you say, let's say there's another building. another building. We will put another building. Let's call this one clubhouse. Let's call this one clubhouse. For now I am not going to draw entirely, but for the explanation in the next video I will draw it if possible. So let's consider clubhouse. So this clubhouse will have gym, pool, this maintaining office, and let's say one masjid beside. Here let's put one masjid. So masjid. So this one also we need DBs. One SMDB here, it will provide everything. SMDB masjid, SMDB clubhouse. So there will be another two. Let's make this one little more bigger. So let's put DB masjid, SMDB masjid. So inside there will be a DB and SMDB clubhouse. So we will put CH. Okay. So this one will have power also. At the same time there will be another SMDB, not SMDB, actually it is MCC panel. I want to tell you something about MCC panel. So let's do REC. No, let's break this one. So we will consider like this. As MCCCH. So normally MCC panel, normally it's connected FCU, AHU. What is FCU? Fan coil unit. It's a AC unit, but in the high level cool. AHU, hair handling unit. It's a unit, but a very high level cooling unit. So whatever related to motor, it can be connected in the MCC. So MCC meaning motor control center. If I am not wrong, what is MCC panel in electrical? So it's look like this, huh? See this one, too much switch. Not all will be like, some little. So a motor control center, MCC, is an assembly to, you can read this one. So normally all the motor related will be connected here. Another advanced information, not advanced meaning another extra information. There is some fan have two speed, and some fan have 3 speed. So there will be, if there is a 2 speed fan, there will be 2 cable to that fan with 2 isolators. So let's say this one 5 kilowatts fan, there will be a 2 isolator for the normal speed and then for the highest speed. So you have to take 2 cable from MCC. Around when I start my job around 5 to 6 years, I don't know this one. So there will be 2 cable if you have 2 speed. So one for the low speed, one for the high speed, and it will be a 6 pole isolator. That means you can provide 2 isolator 3, otherwise 6 pole 1 isolator. I think it will connect together. And motor controller is connected to BMS. BMS meaning building management system. You check every building it has one system. Normally all building BMS, same like that, it will connect with the control this. I will explain you later. So let's consider this will be decide how it will work. So low speed or high speed. And there's another one, VFD drive, variable frequency drive. So the motor have some frequency working. I will type in the Google better. VFD drive, VFD drive panel. This is VFD drive panel. So let's type what is VFD drive panel. Okay, a variable frequency drive. See, they already what is VFD? Already mentioned the motor. So it's a type of motor controller that drive an electrical motor by varying the frequency and voltage of its power supply. The VFD also has the capacity to control ramp up and meaning RPM, right, and ramp down of the motor during start or stop respectively. So you can control the frequency of the motor, you can make speed up and slow up, and I think you can control the RPM. So a frequency, I hope you know, in the electrical up and down in the wave, yes, up and down in the wave there is a frequency. So it's more frequency, I think higher speed of motor, the less frequency, lower speed of motor. This is what I understand. And let's ask Mr. Google if high frequency how VFD affect motor speed. When the VFD reduces frequency and motor speed, it also reduces voltage to keep the volts hertz ratio constant. Torque remain at 100%, but HP reduce and the direct proportion to the change speed at 30 Hz. So it's changing the speed also. If I am not wrong, just check again. The HP is just 50% of 60% and too many things. Read it. Generally, it will control the speed. There is a VFD drive. So learn about this MCC. Generally, all the motor will be connected, which is related to AC, exhaust fan, pressurization fan, which is related to mechanical. You know exhaust fan, you know pressurization fan. If you don't know, check the Google. You may think if I am telling everything Google, so what is the purpose of learning in the YouTube? But I am telling this something related to mechanical, not to electrical. So if it is electrical, I will explain you, but check pressurization fan. Otherwise, if I explain everything, I know what is pressurization fan and exhaust fan. It will waste your time. Just we are going out of the subject. So this MCC panel always connected with pressurization fan, and exhaust fan, AHUs, FCUs, some ACs, everything. So what is AHU? Already I am out of the subject. AHU unit. You type AHU. So if you go image, it's AHU. This is the AHU. Let's consider bigger size of AC unit, which can give cool very big building one time. It have many ducts connected. I will explain you when I am doing some other subject. I maybe explain you. So this is hall. So I don't want to. So now this power supply, to get power supply of how many connected load, I have to draw that one. But it is something like repeating same thing what I did here. It's repeating here. So you can draw clubhouse, masjid and something and put some lights, power, everything, and maybe AC, everything. We will consider same load what I have here. So now what I have extra? Masjid, clubhouse, MCC. So let's keep that. Let's say 100, 100, 100. I don't know demanded load, so I am not going to touch 100. Let's make 0, 0. Let's copy. Remember, I am doing this one learning purpose. If you have more time, make it perfectly. If you have any doubt, just comment for me. I will try to reply. So let's add another 300 kilowatts here. So how much will come? 8 meaning 1145 kilowatts. Okay, so I have 1145 kilowatts total, and here also I have to put another 100 kilowatts. So let's go for 1200. Let's say 1200. Yeah, it not will come that much, but for the safety purpose. Okay, another thing I have to tell you, in the substation there will be sockets LV room, there will be sockets in the MV room and transfer room, even HV room for the service purpose. So this light and this socket cannot be done in the regular cable, especially in Qatar, not other country, I don't know. Especially in Qatar, it will be not regular cable. You have to use MICC cable. It's a metallic insulated cable, something like this. So this is the earthing purpose. So you see this is copper, and this is neutral, and this is phase, and this is the cover. So there is many type of this one. So MICC metallic insulated copper cable. Let's go all. What is MCC? Okay, mineral. Sorry, stand for mineral included copper cable, not insulated. Insulated. Yes, right. Not metallic. Mineral insulated copper cable. This is MCC cable stand for. So this one have special tools. Uh, you see MICC cable tools and gland, everything specialized. So you need these items to work with that. So as a designer or draftsman, you don't have to worry about this. This is all supervisor concepts or foreman or technician concept. But this one has to be learned. They cannot make regular termination. This is a specialized tool. Okay, let's go to the video. So let's come here. I hope everything I clear. We are in the last stage. Now I have here 1245.28 kilowatts. So let's consider 1300. Let's go to the calculator. Mr. Calculator, come out. Okay. So if you have 1300 into let's make 1.54. This is what I calculated. If power factor increase, this one will be changed. So it's 2000 ampere, almost 2000 ampere. So I have 2000 ampere here. Okay. So what we will do, if I have 2000 ampere, I have to add some extra 30%. So that's 30%. So let's go to the calculator. So if you have 100, 30% meaning 130. So what will happen if I divide by 0.7? something coming 142.8 something. So let's go 100 multiplied by 0.3. So it's 30. I thought if I divided by 7, it will come 130. I am wrong, right? Oh no. If I divide by 170, what will happen? Same. Okay, 30%. So let's go for the, I think I got 2000 ampere, right? Even if I multiple with this or that, same. Okay, let's 2000 into 0.3, 600, now plus 2000. So always 2600 amperes. So if I multiple extra 30 add and the ampere calculate, same will come 2600. So I need 2600 here. Oh no, if 2600 there, we have to divide this one. I think I give 0.8 power factor. So it's coming almost 3250 kVA, right? Yes. So if I have watts, let me think. Now I have 1600 kVA. To convert to the power, I am multiplying 0.8. But if I want to convert again to kVA, I need to divide. Let's cancel. Check this. Let's say I have 100 kilowatts. Now if I divide by 0.8, this is 125 kVA. Now if I multiply by 0.8, it's 100 kilowatts. This is the concept. So I have already 1245. Let's go for that. Yeah, I am wrong. I am totally wrong. I should not calculate from the ampere. I should calculate from the watts. I am extremely sorry. So 1245 into 228 multiple by 0.3. 0.3. So 373 something plus 1245.28. So 1618 kilowatts. So 1620 we will consider like this. So if I have 1620, okay, 1620, if I divide by 0.8, so 1300. That meaning this 1300 kVA. That meaning this one is enough. 1600 kVA. It's more than enough. I hope you understand. I have total load, total connected load. I add 30% into this load and then I convert it to kVA by dividing 0.8 because I am using power factor 0.8. So how much I got? 1296 kVA. So the transform I have to select which is near to that one. So here I have 1600 kVA transformer. So it can be fluid power. So before what I did, 1618. So let's consider 1620 multiple by 1.54, 2500 amperage. That meaning this guy. So it's already there. So I don't have to change. This is breaker. So before I confused, I am also normal human, do mistakes, and I am sorry. So this is amperage, and this is total connected load. I add 30%, then I divided by power factor to get the generator. So you can order the generator for 1600 kVA. And there is a two type of generator. No, not generator, transformer. You can order the transformer 1600 kVA. There's two type of transformer. They are dry type and oil type. It's depend on the place you are using. If it is underground something, you have to use oil type because it will keep the transformer cooler. The external you can use dry type. So let's ask the Google. Why I am asking Google? I am little confused there. Sometime I the thing I know 100%. When I am telling someone, sometime I confuse. Little glitch in the brain. Where I can use dry type transformer. Okay, let's get in Qatar. Indoor switchgear. So dry type is indoor. Yes, I mistaken. Oil type outdoor. Check it. As per the country, it can be changed, so it's not very important. It's important. You have to check the regulation. Where I can use oil type transformer. Let's forget the Qatar. Oil compressed power transformer have many benefits, particularly their efficient cooling capacity. They are used in many industries and can be found at both electrical substation power distribution center. So it's a type of transformer. Mostly oil type will be external, dry type is internal. Yeah, correct. Dry type internal, it's logic because we have ACs. Out, we don't have AC, so we need to provide oil type outside. So this one in the transformer room, which is inside the building, so they use dry type. It's correct. Now I remember. And what else? Now how to choose generator? You can use same knowledge what I provided here to use the generator. So this is 300 kVA generator, but how much we have? Let's say 30 30 30 or 50 50 50 50, but you have to originally calculate 200 and 250. Let's say 300 kilowatts. So 300 kilowatts, it's more. You divide again the power factor, it will come some, let's say 300 divided by 0.8. So 375, we will go for the 400 kVA. So let's put 800 ampere as a thumb rule. Yeah, we have generator, so you will update this everything. So this is how electrical will works. I hope I cover everything, I didn't miss anything. So let's run a quick summary. Okay, So let's start from here. We have many sockets which is specifically as per the requirement, like shaver, AC, dishwasher, cooker, everything, and we will take the load and we will make 1 dB schedule, meaning this dB, this size of wire need required this dB providing power to this socket, and this socket need this much wire, and this is the load. And when we take the total load, we will decide the incoming breaker. When we have the total load, we can decide the cable through the Karma book. Otherwise, you have to go to the catalog with the any catalog in your country to select the cable, the first thing. The second thing, as per that load, you will make application form to the government. I need this much power, or if you are, you will get it that power done. This is different thing. If this is big building, it's one project, so it will go to the SMDB. So here you have service cabinet, which is the owner of the full compound will charge through this service cabinet. It will have 1 meter and one breaker. So SMDB, it will have many dBs, something like this, and we will make one SLD diagram like this, and we will take total load. So how many SMDB entire compound, entire full project have, we will collect it here. Make SMDB single line diagram same like this, 1 2 3 4 5 6, and it will goes to MDB. In this MDB, it will collect all the SMDB load and it will give the total load. As per that load, we will select our transformer. In case of there is any emergency supply required, we will choose the generator. You continue from the video, you will understand everything. Okay, and I have teach you how to make calculate the ampere. The capacitor bank, it will balance the powers, balance the MB panel power. I already told you it will balance the load, not load, the voltage, everything. Then yeah, it will balance the voltage V and also the ampere. No, not ampere. You check power factor, it will control the volt. And then what else I told you? Yeah, that's all. So let's go to the power factor. What is power factor? Power factor is an expansion of energy efficiency. Is usually expressed the percentage, and the lower the percentage, the less efficient percentage. Power factor is the ratio of working power measured to kilowatts to apparent power measured to kVA. So it will control the power. Yes. No, this is power factor, the capacitor bank. Power factor is something different. Capacitor bank. Here, the capacitor bank is a system consisted of several capacitors connected to series parallel from energy storage system. The system will help in correcting the power factor. So capacitor bank will be control the power factor. This is what I told, I remember. So this is capacitor bank will control the power factor. So this is how electrical drawing works. And I want to tell you something very important. I am teaching here AutoCAD electrical to how to make drafting. Electrical drawing, how it will work. What are the details you need to provide the drafting. everything. So I am not teaching here electrical engineering. So electrical engineering something different, this advanced mode. Okay, I hope you understand. So here whatever I am teaching here AutoCAD electrical, it is only related to the construction based drafting, a drafting person or the designer person which is required in the AutoCAD. So inside the capacitor bank what is happening, how it is controlling, this is everything electrical engineering thing. This one I am not teaching here. So you should understand first why we are doing this AutoCAD electrical, meaning how to draw electrical designing drawing in AutoCAD. This is the main concept. So if you are all over AutoCAD electrical draftsman, these are the things you have to know to do the drawings. So when you learn this AutoCAD everything, which you follow this one, when you are making a drawing, you will know what you have to do first. So if you are electrical engineer, it will help you. If you are electrical draftsman, it will help you in the jobs. If you are electrical engineer, it will help you how to design. So engineering something, it's this one is the main part, is different, but this one part of engineering. It will not contain 100% everything details. I hope you understand. So when I am creating a panel, I can tell you what will be in the panel, how the panel will work, meaning how it will be distributed, how the breaker will work, about how the breaker will come, how to calculate the ampere. But I cannot teach you what is inside the breaker, how it is triggering. These all things I cannot teach you because this is related to electrical engineering. The same thing what I am telling you, capacitor bank. I am telling you this capacitor bank, why we are putting capacitor bank, to control the power factor. But how it is controlling, it is related to electrical engineering. So from my video, from I have I think made 8 or 9 video, you when you learn this one, you can make a drawing. Even you can design a building. You can design a building 100% it will work with this knowledge. But what is inside happening, if you want to know, this is you have to learn electrical engineering. Let's say computer. You buy CPU, central processing unit, you buy motherboard, you make VGA, and you know you'll connect, how to connect, how to assemble, how to put the cable, what type of cable connecting, these things. It's a different. But how motherboard works, how chips work, how to connect the chips, this is something different. So I am teaching AutoCAD electrical here, whatever I told you, it's like assembling. Computer will work. Same thing, if you assemble parts, computer will work. Same concept here. So if you follow my video from zero, this whole construction will work. You can make a building, you can give this drawing to the Kaharma approval, you can take approval, everything is something different. Anyway, when you give to Kaharma, you give this single line diagram and you put for the approval. They will not ask you how the capacitor bank work. If the requirement, the main requirement, the capacitor bank capacity, the panel capacity, the transformer capacity, okay, they will give the approval. So this is the main thing, the important thing I have teach you. So follow from my video from zero to end, take the knowledge. If you want to go very deep, learn engineering. Nowadays you have many sources to learn, and be a talented guy or talented woman or talented man, whatever you are, takes a good experience and make it. So for now, what is mainly needed to design buildings or compounds or commercial building or anything, this knowledge is enough. So whatever I teach you with the knowledge, whatever I teach you up to now, this knowledge enough for you to design a building or design a house or design anything no need to afraid, you can do with this knowledge 100%. So now for now the electrical concept is finished for the light and power. Inshallah another video series I will make. Also electrical. Electrical meaning doesn't contain only the power and light. It is contain fire alarm, access control. This is one ELV, extra low voltage will come. This is electrical, that's an ELV, extra low voltage. This is LV, something like that, LV. We can call LV low voltage. So extra voltage, access control, fire alarm, we have BMS, we have public systems, and like speaker, and we have CCTV systems is one. So that one very small thing, except fire alarm, it is little deeper. So this small thing also as a designer, meaning as a draftsman, electrical draftsman or electrical designer, what we will do, just we will provide, we need CCTV here, and this CCTV we will put one cable like coaxial cable or Cat6, whatever cable. We will provide the power supply, whatever needed, and we will take to the rack and we will show it's going to CCTV rack. That's all. It's finished. Then specialized people will come. They will connect, do whatever needed inside the panel. So as a drawing, we have to do up to that point. That's all. We don't have to explain inside what is in the panel, how it will connect everything. But there is a ELV draftman. He is only draw that one particularly. He will draw inside the panel everything under the instruction of the specialized engineering guy. So that is different. So which is possible for me, I will teach you maximum in other series of video. I am planning to do fire alarm because I am good in fire alarm, and CCTV and then access control. These are only up to rack, I know, but I will explain in one video. Maybe I will make one short video, then I will explain you how this will work. And the specialized thing, I cannot tell you what is inside the panel, what will happen. Same like what I told you in the electrical, because I am not in that field. Anyhow, I will try to learn myself and I try to put for you. But for the electrical draftsman, this is enough for you. Or electrical designer, if you are electrical engineer, also this will be help you. And the another thing, main important thing, this every socket have certain height of installation. This is depend on the country and depend on the designer. So normally socket 450 from FFL, and the switch 1250 from FFL, 450 meaning 450 mm, and switch 1250 from FFL. Wall mounted type normally we put 2 meter or 2.2 meter, something like that. Panel, top of panel 1.8, or sometimes we go for the 2.2, which depend on the location. And the AC, it's near to the AC unit as much as possible. And in the kitchen, mostly above counter 150 mm we used to cover, or sometime 250. It depend on the architectural requirement. For the TV sockets, it's depend how much height as per the architectural, because the wall mounted TV different height. This is depend on the architectural, you have to check. This is the general height of the installation. Inshallah, we will meet in the next series. I will make fire alarm. I'm good in fire alarm. I will teach you about the fire alarm. The rest of the thing I will teach you the base, and the rest thing you will understand. I will cover maximum 90%. The rest of the thing. Already I cover electrical 90%. Anyhow, I miss some 10%. Fire alarm also I will try to cover 90%, but other system maybe I will try to I try to teach you more about 70 to 75%. The rest I will search and I will put it for you. So until we will meet in next series. Take care, bye, learn, get advantage, and the most very important thing, teach other. If you don't teach other, you will forget. Sometimes you will not forget, but if you teach other, it will benefit you more. Take care, bye, Assalamu alaikum.